Hello friends, welcome to Mech Gains. Today we are going to solve a question from ESE Mains 2022. The question is question first A. I will first show you the question. I have the question paper as I myself have given the mains this year. So I will first show you the question. Then I have already solved this question as of now. In the later videos we'll solve the question simultaneously with the video, but today I have already solved the question, so you will see how to write the answer in the mains paper. So it is useful for the mechanical students and also useful for the other branches also, that like they can make the analogy like how they can write the answers in the mains examination. So I will first show you the question. So this is the question first A. A wooden block of specific gravity 0.75 floats in water. If the size of the block is 1 meter into 0.5 into 0.4 meters, then find its metacentric height. It is a good question, not that hard. It is an easy question, but still it will give you 12 marks. And this type of question nowadays can also asked in GATE. So you have to be very thorough in the concept of this metacentric height to solve this question. So I have already solved this question, I have told. So here is the question and we'll see the solution. So I'll write the name of the channel, Mech Gains. Okay, you can also subscribe to the channel to get the updates for the ESE mains mechanical, for the civil services optional mechanical, and for the DRDO question solutions. You will see how to write the answers. Solution you can find in the solution booklets of many coachings, but the point is how to write the solution by yourself. That is a trick you need to learn and apply in the examination, as you have the limited time in the examination, and in the mains paper, especially in the mains paper, you will always fall short of time. So here is the solution. The question says, you can see the question, a wooden block of specific gravity 0.75 floats in water. If the size of the block is this, find its metacentric height. So we have a wooden block, you can see the wooden block, and I have wrote the density as it tells 0.75 is the specific gravity. So let's assume the density of water to be 1000, then the density of the body will be, here I will write body or block, it doesn't that so matter. So it is the density of the body and it is the density of the water. So I have assumed that it is floating and it has the dimensions of this, and by equating the buoyant forces and the mass of the block, we will equate this because the question tells that it is floating in the water. So the floating condition is the buoyancy force should be equal to the mass of the block. And now we have calculated the submerged volume. Vs is the submerged volume and V body is the total volume of the body. So 0.75 times of volume will be submerged and 0.25 times of the volume will be remain outside the water. It is partially floating. Okay, so we don't know the orientation, in which orientation the body will float. So case 1, what I have assumed is, I have assumed that the surface 1 into 0.5 meter square area, it is horizontal. It means that this length, it is 0.4 meters, it will be vertical, and this area I'm talking about, this area, this is horizontal. So it is a case, it is the orientation which I am assuming in first. You can also assume the other cases. So and will get, and in the case where you will get the GM value, the metacentric height value is positive, that case will be your solution. So I have assumed this, and we have just calculated that 0.75 times of height will remain inside the water and 0.25 times of height will remain outside the water. So the total height is 0.4 meters. So this height will be 0.75 h, this height will be 0.3 meters, and 0.25 h, which will be outside the water, will be 0.1 meters. Okay, so First we'll calculate the center of gravity, which will be 0.2 meters at the center, it's no doubt, and the center of buoyancy. Center of buoyancy will be, this hole is 0.3 meters, so center of buoyancy will be 0.15 meters, correct? Now we'll find the GB. GB will be the distance between B and G, that will be 0.05 meters, and we will also calculate the BM. BM, for BM the formula is, you all know, I said in the start, you should be thorough in the concepts of the floating so as to solve this question. Like we are solving the mains question, so I am assuming you are thorough with the concepts. So this is the BM, I minimum upon V submerged, and we will calculate the I minimum 1 into 0.5 Q upon 12, that comes out to be 1 by 96 meter power 4. The calculator, the Casio calculator, I will show you just the calculator which is allowed in the mains examination, which I have used in my examination. This was the calculator which I have used, so you can also use this calculator in the examination. So there is a not a major problem in solving the questions. You can solve by calculators. So I have calculated this value, and V submerged will be 0.75 times of the total volume, that will be 3 by 20 meter cube. So now I have calculated BM by the ratio I have just calculated, so it comes out to be this, and GM will be equal to BM minus BZ. So BM was this and BZ was this, so we are subtracting BM minus BZ, and we are getting GM as 0.0194 meter. So here GM is greater than 0. When GM is positive, then in that case we have a stable floating condition, right? Yes. So now we have a stable floating condition, which means that our assumption was right. That means our assumption was right, and the body will float here, and the body will float in this condition only. We have to write this. Sorry for this, but I hope you can understand. So we can see that the body will float in this condition only, and the answer GM equal to 0.0194 meter, and you have to show the orientation, in which orientation the body will float. It is 0.4 meters, it is 1 meter, it is 0.5 meter. The body will float in this orientation with the GM is equal to A, and that will be the answer to this question. And after writing all the steps, I will show the steps once again. These are the steps. And after writing all these steps, you will get complete 12 marks. Okay, so thank you for today, and we will be solving later on further questions in the coming video. So all the best.